Okay, so welcome back. This is the part 2 of Introduction to Electronic Communication. This is me again, Engineer Jonathan Montarola. Okay, so in part 1 of the video, I was discussing the significance of the electronic communication, human communications, so the barriers. Okay, so last I also discussed the basic components of the communication system, which is the transmitter, the transmission channel or medium, and the receiver, and as well as the transceiver, which transmit and receive. No, it has a ability to transmit and receive signals. No? So this time I will be continuing the discussion. So in communication system, we have this term attenuation. So signal attenuation or degradation exists in all media of wireless transmission. Even in wired transmission, when the wire is in the outdoor, like for example sa telepono, mainit gay ng kanang wire, so increase po na yung temperature, so that will hindrance the research, no? So it is an opposite of amplification, no? Attenuate meaning ni gamay, degrade. So it is proportional to the square of the distance between the transmitter and the receiver. So meaning to say, when the transmitter is far from the receiver, it will be it will result to attenuation of the signal. You can notice when we have a Google Meet, layo kayo mo, so sometimes mo delay siya o pila ka seconds o na dungog ninyo akong tingog, no? So that is the reason why na attenuation nga nitabo sa tuang signal. Okay, so noise is random undesirable electronic energy that enters the communication system via the communication medium and interferes with the transmitted message. One of the example of noise is thunder, no? Lightning and thunder, no? Nga makapa bungkag sa to ang message. Okay? Sa karaan pa nga cellphone, no? Sometimes ay mo ma-receive message putol na lang. Dali pinas send na siya quote dito, some text missing, no? So one of the example is that noise in radio, like for example na radio, one of the example nga maka-interfere sa signal is ang eroplano, no? So kung EM moagi gani ang eroplano, no, sa karat pod ang iyahang signal, no? So noise na siya, muna gitawag undesirable electronic energy. Electronic communications are classified according to whether they are one-way or that is simplex. If the two-way, that is full duplex or half duplex transmission. And second one is analog or digital. So simplex method of electronic communication is referred to as simplex, no? So this type of communication is one way, sample radio, no? So dili magkaka send og message sa imong radio, no? But sila ray maka send og message. So that is one way. TV broadcasting, dili maka broadcast kag imuha diha sa inyong balay niya makita sa nilang vice ganda, no? Kita silang TV ni vice ganda, so no. So one way na siya, no? Beeper, personal receiver, no? So one way lang na, one way communication ang simplex. Ang full duplex is most electronic communication is two-way and is referred to as duplex. So kung duplex, when people can talk and listen simultaneously, it is full duplex. The telephone is an example of this type of communication. Telepono, pwede ka maka-receive, no? Makabati kag tingog sa imong katawag, and then at the same time pwede sad ka maka-istorya, no? Ma-receive po sa pikas. That is full duplex. Half duplex is two-way communication which only one party transmit at a time, known as half duplex. Sample, police, military radio transmissions. So dili sa pwede nga magsugat, no? So mong usa mo sulti, no? So dili pwede nga mo interfere pod ang pikas linya. So waton gid nga mahuman, no? That is moingon sila nga over, no? Kung moingon na kayong over man sa istorya, pwede na kamo sulti na pod, no? Kung magdungan mo pislit sa kuan push button, istorya magdungan, so dili mo magbati. So one at a time, and then once mo human na istorya, mayngon na nga over. Okay, so citizen band, family radio, amateur radio, no? So that is half duplex. Okay, analog signal. Analog signal is smoothly and continuously varying voltage or current. Example, sine wave, voice, video, TV. So analog signal, okay, sine wave yan ko ano, sine wave or kung voice pod, no, hay pa diyang signal, video, hay pod. So smoothly and continuously varying voltage or current. That is the brief definition of a analog signal. So this is an example. Sine wave tone, no? So letter A kani siya, no? Sine wave tone, a tune, and then voice radio, a voice. Okay, so this is the signal of voice. TV, so signal of video, so mo ni siya. Okay, so complicated siya, no? So from easy nya kanina kanam daghanan ko, depende sa volume sa imong tingog namang goy mahinay, mataas, mahinay. So this is the result. Digital signals, monis lang signal change in steps or in discrete increments. So most digital signals are binary or two-state codes. For example, kato sa una kaning telegraph nya mo gamit og Morse code. Continuous wave code, no? CW. Serial binary code used in computers. Okay? So digital signals. Okay, so this is an example of kanina una, letter A, ano yung telegraph or Morse code, no? So mga dots and dashes meron siya. So mark, space, mark na pod, space, that one. And kaning letter B is a continuous wave. Okay, so ang dot ano siya, and then dashes ano siya signal, and dot na pod. So letter R, no? Dot, the dash, and then dot na pod. So that is R. Letter C is the serial binary code. Nakita nimo dire binary code siya, 010101 lang ang imong diagram. What is digital signal? So digital signals are many transmissions are of signals that originate in digital form but must be converted to analog form to match the transmission medium. So depende no kung unsay suitable sa imong transmission medium. Digital data over the telephone network. Okay, example. Yeah, analog signals they are first digitalized with an analog to digital converter or AD. The data can be transmitted and is processed by computers and their other digital circuits. Okay? So data. So 9 times nga analog ang imong input and then digital ang gikinahanglan sa imong transmission medium. So you need to have A and D converter, no? A and D converter. So modulation and multiplexing, no, are electronic techniques that for transmitting information efficiently from one place to another. Unsa may naani? Ang modulation makes the information signal more compatible with the medium, that is modulation. Ang multiplexing is allows more than one signal to be transmitted concurrently over a signal medium. Okay? One or more, no? Or more than one signal to be transmitted medium, no? Okay, like example here, multiple baseband intelligence signal imong gi-input sa multiplexer or MUX. So dire multiplex na siya dire nga signal, no? Combine man niya dire. Pagabot niya natay modulator. Modulator is unsa gini para mangita sa pagi nga mahimo siyang suitable sa imong transmission medium. So here in modulator we have carrier oscillator, no? Carrier oscillator. So meaning information signal mo so dire, no? And that will become electronic signal. Abot dire, no? There is a carrier oscillator, no? Before ni siya i-send, no? So naanad pud tay RF dire, power amplifier, no? So ang output dire sending out amplifier and then antenna. Antenna that or mo ni ang tiglabay, no, sa signal nga na available. The range of electromagnetic signals encompassing the all frequencies is referred to as kani spectrum. Range. So this is an example of electromagnetic spectrum. Natay LF, BF. Okay, so extra high, extra large frequency, very large frequency, low frequency, medium frequency. Okay, so kindly read your notes na lang, ani. So frequency and wavelength. So first is ang frequency. The signal is located on the frequency spectrum according to its frequency and wavelength. If frequency is the frequency is the number of cycles of a repetitive wave that occurs in a given period of time. So that is frequency. Number of number of cycles of a repetitive wave. A cycle consists of two voltage polarity reversal, current reversals, and electromagnetic fields oscillation. So, muna siya ang cycle. Frequency is measured in cycles per second. So, CPS. And the unit is Hertz. Wavelength is the distance occupied by one cycle of a length and is usually expressed in meters. So meters ang wavelength. Wavelength is also a distance traveled by an electromagnetic wave during the time of one cycle. The wavelength of a signal is represented by lambda, no? Greek letter lambda. Okay, so this is the graph, no? One cycle, no? One 360 degrees yung angle. And then, kayo ha, one wave length. Ang one wave length is this one. This is wavelength, no? Distance or meter. Like example, we have this speed of light. Kung wavelength, pagkuha na to sa wavelength, wavelength is equal to speed of light divided by the frequency. So given that the speed of light is constant, which is 3 times 10 to the power times 10 to the power of 8 no meter per second. So we have 3 times 10 to the power of 8 divided by f. Example na to is kung natay frequency of 4 megahertz, what will be the wavelength? No wavelength na to. So wavelength, no, lambda is equal to 3 times 10 to the power of 8 divided by 4. So we have a wavelength of 70 meters per 70 meters, yes. So frequency range from 30 Hz to 300 Hz. Ano ni ang niya, no? Extremely low frequency. So 30 to 300 Hz. Voice frequencies 300 to 3000 Hz. Very low frequency na today include the higher end of the human hearing range to about 20 kHz. Ang low frequency or LF is 30 to 300 kHz. And medium frequencies mo ni 300 to 3000 kHz. EM radio is 535 minus 1695 1605 Hz. Okay, so high frequencies na siya sa 3 to 30 MHz. Ang example ani government, military two-way communication, amateur radio, and CB. Very high frequencies, mo na yan 30 to 300. Okay, 30 to 300. Mo na yung FM broadcast, with FM radio broadcast, 88 to 108 megahertz during the channel. Ultra high frequencies, TV channels, only 14 to 67, cellular phones, military communication, and then money ang range 300 to 3000 megahertz. Next is microwaves and super high frequencies, SSF. Money ni satellite communication or the wireless LAN or microwave oven. So 1 to 30 gigahertz. Next is extremely high volt frequencies, wala na yung satellite communication or computer data, which is 30 to 300 gigahertz. No, that is the range of the frequency. No, frequency. Optical spectrum. No. Next is optical spectrum. Exists directly above the millimeter wave region. So there are three types of light waves: infrared, visible spectrum, and ultraviolet. Here, first is infrared. Infrared radiation is produced by any physical equipment that generates heat, including our bodies. So, muna ang infrared radiation. Infrared is used as astronomy to detect stars and other physical bodies in the universe. Second is for guidance in weapons systems, where the heat radiated from airplanes or missile can be detected and used to guide missiles and to target. In most new TV remote TV remote control units where special coded signals are transmitted by infrared lead to TV receiver to change channels, set the volume, and perform other function. So in some newer wireless LANs and all fiber optic communication, so dati infrared nang gamit. Visible spectrum, just above the infrared region, muna yung visible spectrum we refer to as light. So red is low frequency, ang long wavelength light. Ang violet, high frequency or short wavelength light. So light waves very high frequency enables them to handle a tremendous amount of information, and the bandwidth of the baseband signals can be very wide. Okay, that is visible spectrum. Next is ultraviolet. Is not used for human communication. So its primary use is medical. Ultraviolet. Next is bandwidth. Bandwidth is that portion of electromagnetic spectrum that occupy by a signal. That is bandwidth. Electromagnetic spectrum. Channel bandwidth refers to the range of frequencies required to transmit the desired information. So that is channel bandwidth. Now, most circuits in electronics communication are used to manipulate signals to produce a desired output. First is signal processing circuit is gain and attenuation. Next is first is gain. Gain means amplification, no? Murag amplify ni man ang signal. It is the ratio of circuit's output to its input, no? So we have this one, no? V out over Vn. So example, this is the amplifier and we have the input signal here. So iyan ang padako ng signal, and then mo na iyang i-release, no? So A is equal to gain is equal to V out over Vn. So most amplifiers are also power amplifiers. So the same procedure can be used to calculate the power gain, EP, no? Where Pn is the input power and the Pout is the output power. Okay. So power gain, E sub P is equal to Pout divided by Pn. Like for example, we have this power output of an amplifier is 6 watts. The power is gain is 80. So what is the input power? So we have 6 divided by 80. So we have 0.075 watts, or that is 75 megawatts. Okay, so the overall is cascaded, no? Cascaded when two or more stages are connected together. So the overall gain is the product of individual circuit gains. Okay, we have this one. Cascaded amplifier have power gains of 5.3.7, no? Gains have 5, 2, and 17. The input power is 40 milliwatts. What is the output power? So imo lang i-multiply tanan nimong power gains, no? So 5 times 2 times 17, we have 170. So Pout is equal to average gain, no, divided times the Pn. So we have total of 6.8 watts output power. Attenuation refers to the loss introduced by a circuit or a component. If the output signal is lowered in amplitude than the input, the circuit has loss or attenuation. No? So, ni-attenuate siya, ni-gamay siya sa original. The letter A is used to represent attenuation. So, attenuation A is equal to output over input, or that is B out over Bn. Circuit that introduce attenuation have a gain that is less than 1, no? So less than 1. With cascaded circuits, the total attenuation is produced is the product of the individual attenuation. We have this one, no? Bn is equal to 3 volts. Low stage, no? Dire na kay loss nga iwan nimo nga 0.2. Nya low circuit nimo kay another low circuit kay 0.9. Then you have loss components which is 0.06. So to solve for the total attenuation is you're going to multiply all the losses. So 0.2 times 0.9 times 0.06 is 0.0108. To solve for the B out, multiply lang nimo, no? Mao ni ang total. So we have 0.034. So meaning you have 32.4 millivolts nga V out, no? 34.4 millivolts ang output nimo dire. So decibel. The decibel is the unit of measure used to express the gain or loss of a circuit. So the decibel was originally created to express sharing response. The decibel is 1/10 of a bill, no? 1/10 of a bill, 1/10. When gain and attenuation are both converted into decibels, the overall gain or attenuation of a circuit can be calculated by adding individual gains or attenuation expressed in decibels. Okay, so this is decibel calculation. For voltage gain or attenuation, dB is equal to 20 log V out over Vn. Current gain, 20 log I out over In. And power gain or attenuation is 10 log P out over Pn. Okay, so example, we have an amplifier has an input of 3 millivolts and an output of 5 volts. What is the gain in decibel? So use this formula, 20 log V out over Vn. So we have V out which is 5 volts divided by 0.003. So we have 20 times 3.22, which is in dB we have 64.4 dB. No? Another example, a filter has a power input of 50 milliwatts and the output of 2 milliwatts. So what is gain or attenuation? So we have P out which is 2 milliwatts and 50 milliwatts ang iyahang input. So 10, so lag kuan man power man, so 10 log 0.04. So that is ang log 0.04 is negative 1.398. So times 10 mo, so you have a dB of negative 13.98. Okay? So since if the decibel figure is positive, that denotes a gain. Kay kani negative man, so that is attenuation. Attenuation. Okay, so that's all for this meeting. So I hope you learned something. Thank you and God bless everyone.